Recording now. Okay. Hello. Uh, um, Assalamualaikum. My name is Muhammad Azbe. So the ID to cost to 2024 6708 class M3CS2554A plus course code ID 440 network programming. So today I'm gonna talk about scalable file, dollar simulator, performance analysis using sequential, concurrent, and parallel programming. So my mission objective in modern computing system, performance and efficiency are critical when handling large-scale tasks. Traditional sequential execution become a bottleneck while processing thousands of operations. This project introduced a scalable file generation method designed to evaluate and compare the execution methods, which is sequential programming, concurrent programming, that is thread pool, and parallel programming process pool. The hardware environment is hardware environment. The hardware that I use is at least multi-core CPU, memory, minimum at least 4 GB RAM, operating system, Windows, Linux or Mac OS, and programming language which is Python 3 point something like that. The library used is Concurrent features, multiprocessing, and matplotlib. It is optional for this one. The environment guide, the setup environment is in this one. MKD Pala download simulator, CD Pala download simulator, pada MV Burn script activate, pip install matplotlib. So I'm gonna launch program, pada Pala download simulator pool.py, which is this one that I put in Visual Studio Code. So I'm gonna try to run it, run. I'm gonna try run but debugging because for some reason it's the so turn ahead, let's close this one. So I'm gonna try eh, ish, what ya? I don't know why I put this code here, but it's 5,000. So we're gonna wait for a while because sequential is a bit slower. I'm gonna skip this video ahead. Okay. So the process one is completed already. So as you can see here, when I type 5,000, uh, for the sequential, its time is 156.79 seconds. Thread pool, which is what we call concurrent, which is 8.02 seconds, which is the fastest one, and process pool, which is parallel programming, which is 14.24 seconds, which is in a not the fast, nearly the fastest, but not the slowest, which is in the middle. So as you can see here, thread pool is the fastest for this workload. Process pool is faster than sequential but slower than thread pool, and sequential is the slowest. So as you can see the power graph, which is uh that I do before, you can see that sequential is so slow, while thread pool is the fastest, and the process pool is in the middle of it. So how does it work? The system simulates file download tests using both I/O and CPU workload. Time point sleep is simulates I/O delay, and loop computation simulates CPU work. So the execution model for that is sequential, execute tasks one by one, but there is no optimization. Thread pool, which is concurrent, it is use multiple threads, best for I/O bound tasks, and allow overlapping execution. For process pool, which is parallel, uses multiple CPU cores, execute tasks simultaneously, and suitable for CPU bound tasks. The key insight for this one is thread pool perform best because the workload is probably I/O bound, allowing threads to overlap waiting time efficiently. Process pool introduce additional overhead, making it less efficient for this specific scenario. So the conclusion for this one and the future improvement, the conclusion execution is inefficient for large scale tasks. Concurrent programming improves performance significantly. Parallel programming is powerful, but it depends on workload type. The final body for this one is choosing the correct execution model essential for achieving optimal performance. Feature improvement include add real-time monitoring, increase number of tests, one 100,000, 100,000, combine threading and multiprocessing, and improve graph visualization. So I try to use two thou- two thou- two 2,000 more than 5,000. But if I use this one to 200,000 or 100,000 each, make it way longer, which is I try to use this one 2,000, 2,000 to 20,000, which is make it more, uh, del- make it way longer than it is. So that's why I cut it to 5,000 to make it easy for the task. So that's why I use 5,000, not to to ha to until to 20,000 to 20,000 for to speed up the task in this one. So yeah, if I can do two, but it's too long for this one and this one too. So this delay, even though it use CPU cores use 12 and 10.23 faster. So yeah, 12 use 12 too, but yeah, something like that. So yeah, that's all for today. So this is the code for this one. Oh, let me, okay, graph, which is cannot use. I don't know. I don't know how to install it. Map for flip. So if I skip, okay, that's all. So yeah, that's all for today. Thank you for watching a bit. Bye bye. Goodbye. Assalamualaikum.